Hello everybody, in this presentation I will discuss the difference between populations and samples, and I will describe several sample selection procedures. The presentation also includes a brief discussion on data collection methods and a short description of surveys. Statistics, the science of data, helps us respond to questions about a group of individuals. For instance, we may want to find out whether college students feel more comfortable communicating with their instructor through email or face-to-face. In this case, we first have to narrow down our question and determine the population of interest. Are we talking about undergraduate or graduate students? What is their year of study? Are they in the first year or the last year? Let's say we're interested in first-year graduate students. This will be our target population. A population is defined as the entire group of individuals about which we want to obtain information. But even when we narrow down our population, in most situations we still cannot collect information from every individual in this group. There are some research projects for which data are collected from the entire population, such as the US Census or state-level standardized assessments. Nevertheless, for most research projects, collecting data from the entire research population is just not feasible. For instance, for dissertation research, it would not be realistic to plan to collect information from every graduate student in the state. So, what do researchers do to be able to answer questions about a population? What they do is select a sample. A sample is a part or a subset of the population from which researchers actually collect data. Information from this group is then used to generalize the results to draw conclusions about the entire population. The process of drawing conclusions about a population based on a sample of data is called inference, because we infer information about the population from what we observe in the sample. Every research project must include a sample design, which means that it must clearly describe the sample selection procedure. The sample selection procedure is crucial in the design of the study because it has direct consequences on the generalizability of the results. To be able to generalize our conclusions, the sample from which we're collecting information must be representative of the population. A representative sample is a subgroup from the population that has the same demographic characteristics as the population of interest. For instance, in our example, we would have to make sure that we select the same proportion of males and females as in the entire population of graduate students, and that the percentage of individuals from every racial group is the same as the population percentage. If there are, say, 40% African American first-year graduate students in the population, then our sample, although much smaller, should include the same proportion of African American students. And the same rule would apply for every other racial group, of course. In studies where participants' social and economical status is important and may influence the results, we may have to make sure that the sample includes the same proportion of each SES subgroup as the entire population. For instance, if you would like to know whether college tuition has an impact on how students feel about their university, it is important to include both students from low SES families as well as students from high SES families and students from middle-class families in the same percentages as in the entire population of students. If any of these groups are underrepresented or overrepresented, the results of the study will be biased. For instance, if the majority of the students in the sample have a high SES, then we would probably not find a significant relationship between tuition costs and their attitudes towards their university. The results of a study are biased when certain outcomes are more likely to occur due to flaws in research design. The sample selection procedure is one of the factors that may lead to biased results. An inappropriate method of selecting a sample is convenience sampling. With convenience sampling, researchers don't really have a sampling procedure. Individuals are selected simply because they are easily accessible. For instance, if we use our example with graduate students, a convenience sample would be administering a survey to your classmates or some other students that you know and can access analysis easily. The problem with convenient samples is that they may lead to biased results, and that results have a reduced generalizability. For instance, if only students from the nursing program or the school improvement program or the counseling program are included in the study, results cannot be generalized to the entire graduate student population. Another sampling procedure that reduces the generalizability of the results is a voluntary response sample. This sample consists of individuals who volunteer to respond to your questions or to fill out a survey. These are typically individuals who respond to a broad appeal, such as mass emails. If you sign up in various graduate student listservs, you will see that some graduate students send emails to recruit volunteers for their dissertation research. This may work for qualitative research where generalizability is not necessarily a goal, but it certainly compromises the quality of quantitative research. Another example of this type of sampling are the ratings or the reviews that you often see online for different services. When looking at these ratings, you always have to keep in mind that the sample was self-selected. And the major problem with the self-selected samples is that individuals with strong opinions are more likely to respond. Individuals who either really liked or really hated something are more likely to provide a rating. Other people with a more neutral attitude are less likely to spend time to fill out a survey or to provide a rating and are therefore underrepresented. The question you may now have is, how should we select a sample? The ideal selection procedure is a random selection. A simple random sample includes individuals who are selected in such a way that every individual in the population has an equal chance of being selected. To do this, we first have to create a comprehensive list of every individual in the population and then use a random selection procedure to select the sample. The random selection procedure can be any procedure that yields uncontrollable results, tossing a coin, rolling a dice, drawing names from a hat. These are all random selection procedures. However, for research projects, we may use a more high-tech method and let computers randomly select individuals from a data set. Another method that can be used, but it's more time-consuming, is using a table of random digits to randomly select a sample. I'm not going to talk much about this method because it is not very practical and it is not used very much anymore. But just in a nutshell, there are two steps in this procedure. First, each individual in the population is assigned a numerical label of the same length. The second step is to read from the table successive groups of digits of the length assigned as labels. The sample will then contain the individuals whose labels were found in the table. As I mentioned earlier, the ideal way of selecting a sample is a random selection, but the random selection does not necessarily yield a representative sample. For instance, in our example, the percentage of females and males who are randomly selected may not be the same as the population percentages. The same may be true for racial groups. So the question is, how can we ensure that every individual in the population has an equal chance of being selected and at the same time obtain a sample that resembles the population? We can do this by using a stratified random sampling procedure. There are two steps in selecting a stratified random sample. First, we divide a population into the groups that need to be represented in the sample. These groups have similar characteristics, are more homogeneous. They are also called strata. For instance, we separate a population into different racial groups. The second step is to select from each group a simple random sample. The proportion of individuals selected from each group must be the same as the population percentage. For instance, let's say that 60% of our population of graduate students are white, 30% are African American, 5% are Asian, and the other 5% are of other ethnicities. We first group the individuals into 4 groups based on their ethnicity, and then we randomly select 60% of our sample from the white group of students, 30% from the African American group, 5% from the Asian group, and the other 5% from the group of students with other ethnicities. If our sample has a total of 100 students, of course this number is too small, but I chose it just to explain this better. We would randomly select 60 white graduate students, 30 African American students, 5 Asian students, and 5 students of other ethnicities. If the sample size is larger, the number selected from each group will increase, but the proportions will stay the same. One thing that you may ask yourselves is, why is random selection the best option? It's because results based on random samples are supported by the laws of probability. If several different random samples are selected from the same population, results are not going to be drastically different between these groups. Furthermore, the laws of probability ensure that the results are generalizable to a certain extent to the entire population. For each set of results, we can compute a margin of error as an index of estimation precision. The larger the random sample, the smaller the margin of error. This means that results based on large random samples are more precise, are more accurate estimations of the true values. Although random samples have so many advantages, in social sciences there are rare instances when samples are truly randomly selected. This is not because researchers are not knowledgeable enough, but because this procedure is not very feasible. We don't always have access to information about all the individuals in the population, and even when we do, we may not gain access to the randomly selected participants. When a truly random sample is not feasible, researchers must apply the principles of sample selection in the situation given to increase as much as possible the generalizability of the results. Furthermore, researchers must carefully interpret the results of the study without overstating their significance, and also they must specify the limitations. After selecting a sample, we have to think about a data collection procedure. The data collection method depends on the type of information that we're interested in. In social sciences, we are most often interested in the opinions or attitudes that a group of individuals has about certain topics, and this information is collected using surveys. Surveys are data collection instruments that contain a set of items. Items are questions or statements for which respondents must indicate their degree of agreement. Responses are typically provided on what we call a Likert scale. A Likert scale consists of a series of responses that range from negative to positive and have a series of intermediate points in between. For instance, we often see agreement scales that have 4 points and range from strongly disagree to strongly agree. The number of levels on a Likert scale depends on the researcher. He or she is the one who should decide how many levels provide the information that is needed to respond to a research question. However, many researchers advise against using scales that have a neutral point in the middle because this information is difficult to interpret when included in statistical analysis. Of course, oftentimes we want to investigate whether a respondent's beliefs about certain topics are related to other more concrete information, such as their test scores or some demographic information like age, gender, and so forth. Demographic information may also be included in the survey. Student performance data may be available from a public database, or we may administer a test, for instance, and use our own assessment results. When interpreting results from survey research, we always have to keep in mind that the information we're using is what we call self-report, and self-report is always subjective. It is the individual's perception of certain facts and not the actual facts. For instance, students may indicate in a survey that they perceive their instructor as being too demanding, but their overall feeling may be influenced by many other factors, such as the instructor's or the colleagues' attitudes, the difficulty of the subject matter, and so forth. Furthermore, different students may have a different understanding of the word demanding. Some students may consider demanding a course for which they have to study every day of the week, whereas others consider that having to read a chapter a week is too demanding. And this leads us to another issue, which is how to formulate good survey items. There are many guidelines for designing a good survey, and if you ever have to do it, I recommend studying this topic a little more in depth. I am just going to mention a few major rules that we always have to keep in mind. Avoiding response bias, avoiding negative wording. Sometimes even if we are not using negative words, but if the sentence has an overall negative meaning, then responses may be biased. Also, avoid ambiguity. Statements must be very clear, leave no room for interpretation. If any of the words have some degree of ambiguity, the item is compromised. Another problem that often occurs in survey design is the fact that individual items ask more than one question. For instance, I feel confident that I will successfully complete my coursework and my dissertation research. This statement is very poorly constructed and includes several mistakes. First, we shouldn't use I feel. This is too subjective. As researchers, our aim is objectivity, so I am confident would probably be a better beginning for this sentence. If a student indicates that he strongly agrees with this statement, as researchers, how can we determine whether he feels the same way about the coursework as he does about the dissertation research? These are two different things. Even students may feel confused when trying to answer this question, so we should have two separate items for them. Another issue here is including the word successfully. What does successfully mean? Is it just passing the courses or having a 4.0 GPA? Different students may have a different understanding of what success means, and we have no way of knowing what each one of them has in mind when they answer the question. Other issues that we need to be aware of when we use surveys to conduct our research, and with any other data collection procedure for that matter, are undercoverage and non-response. Undercoverage means that a certain section of the population has not been included in the sample selection process. For instance, in our example with graduate students, a researcher may not include the graduate students in online programs who are not physically present on campus. Of course, we should keep this in mind when designing a study and avoid excluding anybody. However, in some situations, it's just not possible to obtain information about some individuals. In this case, we should make a note of this and mention it as a limitation of our study when we report the results. The other issue is non-response. When a survey is sent out, but some individuals do not return the survey or do not respond to some of the questions, a large proportion of non-response can compromise your study because your sample is not representative anymore. Plus, your sample size might be greatly reduced. To avoid non-response, you should inform and emphasize to participants the importance of your study and the importance of their participation, and ensure them of the confidentiality of their responses. This concludes my presentation on sampling and quantitative data collection procedures, but I included here some additional references that you may find helpful if you would like to learn more about these topics.